നെറ്റ് കിട്ടുന്നില്ല. ആ ഓക്കെ. ഞാൻ പറയാൻ മറന്നു, സോറി. Hi students, can you hear me?
Sir.
Sir.
Thank you. We will start the class. Before that, please put your attendance in the command window. Today, fourth and fifth hour will be mechanics of solids, and the final hour will be mechanics of fluids. There is a small exchange due to some technical change. So we have exam on next week, this week. So we will revision those parts firstly, because if you have any queries, you can ask now. First of all, very main question will be about shear force and bending moment diagram. As we have already studied, we need to focus on shear force and bending moment diagram. For that, we will do some example problems. The basic problems we will discuss, and some students have sent the answers of yesterday's problem, and that should be appreciated. And other students should do the problems, because then only you can pass the examination. If once a supplementary exams comes like MOS, that will be a huge trouble on you in upcoming semesters, because studying MOS is very difficult compared to all other subjects in S3 mechanical. So prepare well. And when I look your problems, even the students who have done the calculation have done some mistakes. So that mistake should be corrected by themselves by looking the problem which I shared in the WhatsApp group. Also, some students are requested to submit their remedial measures class, that I will read the names. Abhinand K. Where is Abhinand?
Yes, sir.
Hello, Abhinand. Why you are not submitting that first module, first series question paper?
കുറച്ചുകൂടി എഴുതാനുണ്ട് സാറേ.
ആയിരത്തോളം ഇപ്പം അയക്കണം കേട്ടോ. എത്രത്തോളം എഴുതി എന്നുള്ളത് നോക്കാൻ വേണ്ടിയിട്ടാണ്. You should send whatever you have done till now. And Adarsh P. Adarsh Praman? Adarsh?
Yes, sir.
What about you?
Hello.
Hello, tell me. What
Indineka.
about you? Okay. And Agash C. Dilip?
Sir, കുറച്ചുകൂടി ആൻസർ ചെയ്താണ്ടേനു.
Indineka.
ഇന്ന് തന്നെ അയക്കണേ. എല്ലാവരോടും പറയുന്നതാണ് ഞാൻ. ഓരോ ആൾക്കാർ: അലൻ, അമർനാഥ്, ആനന്ദ്,
Yes, sir.
അർജുൻ, ഹൃതിക്, കാളിദാസ്, മർസൂഖ്, ഷെറിൻ, സൈൻ അഷ്റഫ്, and Nihal Abdul Nazir Amke. എല്ലാവരും ഇന്ന് തന്നെ അയക്കുക കാരണം ബിക്കോസ് നാളെ മുതൽ ഇവിടെ ഓഡിറ്റ് ആണ്. സോ ഐ നീഡ് ടു സബ്മിറ്റ് ദ പേപ്പേഴ്സ് ഓൾസോ. So it's mandatory. If you help me, I will help you. That's a mutual understanding. Even the answers are wrong, we will correct it. No issues. Please write it. Okay. You have good students in your classroom, so you can take their help as well. So don't late for anything because if you are supporting me, I will definitely support you in every cases. In even marks, you will get good marks if you perform well. And when I am going to explain SFN BM diagram, those students who are asked to write the remedial measures, please concentrate on this part because in the upcoming examination, such problems will be asked in your question paper. That is serious exam. If you prepare well, means in the next examination, there is no need to write the remedial measures. You will definitely pass the examination. This is mandatory. So first of all, we will discuss a problem, simple problem. It's a cantilever beam. You can see a cantilever beam of length. Total length will be 2 meter. You can check it. That is 0.5 plus 0.7 plus 0.8 meter. When you cumulate it, 0.8 plus 0.7, 1.5 plus 0.5, that all dimension will become 2 meter. And there are 3 point loads acting on the beam. One is 300 Newton. Second one is
Sir,
5.
slightly more. Slide
മാറുന്നില്ല. So, 1 minute, 1 minute. I think some network issue. 1 minute. Now is it okay?
Yes, sir.
Okay. Now there is a problem of cantilever beam having 3 point loads at different points B, C, and D. And the values are 300, 500, and 800 respectively. And distance can be expressed as 0.5 meter, 0.7 meter, and 0.8 meter. So total length will be 2 meter. So you need to draw the shear force diagram and bending moment diagram. So first of all, you need to draw the shear force diagram. For that, we will take dimension from the right hand side, that is point D. From point D onwards, we will find the values. So when you take the point D, where you must remember the sign conversion. For that, we have given you an example, that is a small word that is run R Q N. Please remember this thing. If a beam is there, if there is a right upward force, that is RU, right upward force, that is RU. If there is a right upward force, then that will be negative. And obviously, right downward force will be positive. If you start from opposite side, from this side, this will be exactly opposite. That is, left upward force will be positive. Please note down, this is an important thing. And left downward force will be negative. This is very important when you are starting. If you are starting from this side, in this direction we are solving, means you have to take this sign conversion. If you are taking from this side to this direction, then you have to take this sign conversion. This is mandatory. From which side you are doing, that's important. And in case of movement, same beam can be taken. This will be straight line. When I am drawing, there will be small bulbs. So when you are taking a beam like this, there will be two kinds of movement. If you are taking all moments from this right hand side, anti-clockwise will be positive. Sorry, anti-clockwise, not clockwise. This is clockwise. Sorry. anti-clockwise will be positive and clockwise will be negative. Similarly, when you are taking here, the anti-clockwise will be negative and clockwise will be positive. ഈ സൈഡിൽ നിന്ന് ഇങ്ങോട്ടേക്കാണെങ്കിൽ. So it's very important whenever a beam is considered and the forces, that is shear force, if you are solving from right hand side, please remember this relation, that is run. That is run. So when you are seeing this run relation, that is right upward force will be negative. That is a basic. From that you can derive all the relation. When right upward force is negative, right downward force will be positive, and similarly you can do every calculation to this side. And if you are starting from left hand side, then left upward force will be positive, left downward force will be negative, and you can solve everything to this direction. And similarly, when you are taking moments in right hand side, when you are taking moment, anti-clockwise movement will be positive and clockwise movement will be negative. Very important. Anti-clockwise movement will be positive and clockwise movement will be negative. And when you are taking from left hand side in this direction, clockwise movement will be positive and anti-clockwise movement will be negative. If you don't know, please note down this point. This is very important point for you to write the examination. If you made any mistake according to this one, that will create a lot of problem in the examination, as well as you may chance to fail. If you are following all this sign conversion properly, you can pass the examination very easily, because sign conversion makes the answers right or wrong. It's very important. Okay, first of all we will determine shear force. So for that we need to consider, I'm solving from the right hand side. Since it's a cantilever beam, it's very difficult to solve from left hand side because there is no force in the left hand side directly available. So when you are taking D, there will be a right downward force, that is 800 Newton, right downward force 800 Newton. So right downward force is denoted as positive. So obviously this 800 will be positive side. Right downward force, so 800 will be positive. So that is given here. Shear force at D, FD equal to positive 800 Newton. And you can draw the line. This is the baseline, that's denoted here, baseline. From that 800 should be marked on the top side, because that's positive value. So after that we will take another point, that is C. When you are looking C, point C, then you can understand that there is a force already 800 and here there is a force 500. So the shear force at C will be 800 plus 500. The direction also should be monitored, because you are doing from right hand side to left hand side. So up to upward, lower, downward direction is positive. So here also that force is downward direction. So total force will be positive 1300. Or in this case we have drawn till E. After that we need to draw a horizontal line, because there is no force from E to F. That's why there is no load. After that, from F there will be an increment of 500. So from baseline the total value, that is C to G, will be 1300 Newton. It's very important, 1300 Newton. After that you need to calculate shear force at point B. For that we need to consider all forces up to B. That is, there will be positive 800, there will be positive 500, and there will be positive 300, because all the forces acting in the downward direction. So cumulatively shear force at B will be 1600 Newton. Shear force at B will be 1600 Newton. So finally, you need to find shear force at A. And when you look here, already we have 1300 G and there is no force till B. So from there you can see that there is an increment of 300 Newton. So the final value will be 1600. That is BI length will be 1600, or after that till A there is no another force. So if you take for load at point A, the for load will be 1600 as we have getting from point B. There is not much difficulty. You can directly draw these all values from the diagram itself. If you have doubt, you can ask me. Else you can write the problem. I will show the problem. You can write the problem. Whether this problem is written in your notebook, then no need to write again. We will go as a revision. If the values are different, or if you want to write again, means that will help you. Definitely you will understand shear force and bending moment diagram easily. So write a cantilever beam of length 2 meter, a cantilever beam of length 2 meter, a cantilever beam of length 2 meter carries the point loads, as shown in the figure. As shown in the figure. Draw SF and BM diagram for cantilever beam. Draw SF and BM diagram. Draw SF and BM diagram for the cantilever beam. SF and BM diagram for the cantilever beam. Then you need to draw the figure, and you should be very careful that after the figure you need to draw the shear force diagram as well as bending moment diagram. So you need to prepare that page only for that drawing, and you need to write everything on the other side. Hope you are understanding, because this kind of problems has been done by us. So when you are drawing the figure, you should give an important area. You should give, after this figure, you need to draw another figure at the bottom, and after that you have to draw another figure at the bottom. So there is 3 figure in a line. So you should allocate the paper as such. Draw the figure. I will show the shear force diagram figure, because in that figure you can note down the values of shear force diagram as well as you can draw the figure. Some people maybe drawn the figure, so don't waste it. Actually, this is SF diagram. This is SF diagram. Have it drawn? Can I change the slide? Have you drawn the figure? Okay. Okay.
സാറേ അത് ഉള്ളിൽ എന്തിനാ ഒരു പോസിറ്റീവ് സൈൻ ഇടുന്നത്? ഇതെല്ലാം വാല്യൂസിന് പോസിറ്റീവ് എന്ന് പറയുന്നത്.
യെസ്, ആ പോസിറ്റീവിന്റെ അർത്ഥം കിട്ടിയിരിക്കുന്ന എല്ലാ വാല്യൂസും ബേസ് ലൈനിന്റെ മുകളിലാണ്. ദാറ്റ് ഇസ് പോസിറ്റീവ്. ദാറ്റ്സ് വാട്ട് ദാറ്റ് മീൻ. നോട്ട് നെസസറി.
Okay, sir.
Okay, thank you. After that, you need to draw the bending moment diagram. For that, you should find bending moment at each point. For that 1 minute, I will take the figure here. Okay, for finding bending moment, we have the figure here. For this shaft, for this beam, we know we should find the bending moment. For that bending moment, also I am calculating from the right hand side. That is, when you are looking at the point D, you can see that there will be a load 800 acting at the point D, and you know that bending moment is the multiplication or product of force and perpendicular distance. So when you are looking here, the load is acting at point D where the distance is 0. So bending moment at the point D will be 0. So there is no need of calculation. 800 into 0 will become 0. So you can write it as bending moment at D equal to 800 into 0 equal to 0. Since this is acting in the downward direction, obviously this will be acting in a clockwise direction. Whether when you are taking C, point C, I will take the point C, 1 minute. When you take the point C, you can see that according to this point, this load 800 will be acting in this direction. And due to that moment, the moment will be acting in the clockwise direction, right? According to C, due to load, the load will be acting in the clockwise direction. So the moment will be negative. If you are taking any data from the right hand side to left hand side, the moment will be negative if the moment acting in the clockwise direction is very important. So when you are looking point C, the load is 800 Newton and acting distance will be, this distance will be 0.8 meter. So bending moment at C, that is MC, is equal to minus 800 into zero point 0.8 equal to 640 Newton meter, and it will be in the negative sign because that is acting in the clockwise direction. It's very important. The bending moment at C will be 640 Newton meter. Okay. After that, you need to find bending moment at point B. When you are looking here, this will be two loads acting in the right hand side of point B. That is, one force will be acting in the clockwise direction and another one also will be acting in the clockwise direction. So both will be in clockwise direction. So the sign always will be negative for both cases. Okay. In this manner only that force is acting. That's why I am showing you. According to B, C's force acting at C will be in the clockwise direction. According to B, force acting at D also will be in the clockwise direction. So both forces will be in the negative side. I drawn that figure only for your reference. So you know that there is 800 into distance. B to D distance should be taken. That is 0.8 plus 0.7. Cumulatively, that will become 1.5. And when you are taking C, there will be 500 Newton into distance will be BC. That is, you can directly taken that as 0.7. No need of such explanation. This is not required. 500 into 0.7. 500 into 0.7. The final answer will be 1550. 1550 at B. Now we will select another point, that is A. When you are taking moment about A, similarly, whatever we have done, 800 into total distance, that will be 2 meter, that will be negative, and 500 into 0.7 plus 0.5, that will be 1.2. No need of this step actually. You can directly write this one. 800 into 2 minus 500 into 1.2 and 300 into this load into AB distance, that is 0.5. When you are taking that, you will directly get the bending moment at point A. These are the bending moment. You can summarize the values, that is bending moment at D is 0, bending moment at C is equal to minus 640, and bending moment at B is equal to minus 1550, and bending moment at A will be minus 2350. These are bending moments. And when you are calculating, you can have the figure, because for point loads, that bending moment will be in inclined line, straight line. So from all points, you need to draw this. So first of all, calculate this one. After that, we will draw the figure. As you know that, you can directly draw itself. Please write down bending moment diagram relations. Have you completed this one? Can I change the slide? Tagesh?
Yes, sir.
കഴിഞ്ഞോ?
Ah,
Okay. So you need to draw the shear force and bending moment diagrams. As we have an example of that, and you can draw according to this data. And here also you can see that there is a minus sign to show that all data is below the line. Actually, this is the baseline for bending moment diagram, and this is the baseline for shear force diagram. And you should highlight which is shear force diagram and which is bending moment diagram. This will be shear force diagram, which is already we have marked. And this is bending moment diagram. Please draw both diagrams. We are having very less time. Afternoon at 2 p.m. MOS will be the subject, and after that, last hour will be handled by Srivas sir, mechanics of fluid.
സാറേ ഇതിപ്പോ നെഗറ്റീവ് വാല്യൂ
സെം എക്സാമിൻ്റെത് ഡേറ്റ് എനിക്ക് കറക്റ്റായിട്ട് അറിയില്ല. 22 വരെയല്ലേ നിങ്ങൾക്ക് ക്ലാസ് ഉള്ളത്?
ഫെബ്രുവരി.
ഫെബ്രുവരി 22, 25 വരെയാണ് അക്കോർഡിംഗ് ടു KTU അക്കാദമിക് കലണ്ടർ ഉള്ളത് തോന്നുന്നു.
മാർച്ച് സെക്കൻഡ് വീക്കിൽ എക്സാം തുടങ്ങുന്ന പറഞ്ഞത്.
അതെ, ഡേറ്റ് ആയിട്ട് വന്നിട്ടില്ല, കാരണം S7 ഇപ്പം റീഷെഡ്യൂളിംഗ് നടത്തിയിട്ടുണ്ടായിരുന്നു. സോ വി കനോട്ട് സേ ദാറ്റ്. ഹോപ്പ്ഫുള്ളി മാർച്ച് സെക്കൻഡ് വീക്ക് തന്നെ നമുക്ക് പ്രതീക്ഷിക്കാം, കാരണം വി ഹാവ് ടു ബി പ്രിപ്പയർഡ് ഫോർ ദാറ്റ്. അതിലൊരു കാര്യം ഒരാൾ ഡൗട്ട് എന്തോ ചോദിക്കാൻ വന്നിട്ടുണ്ടായിരുന്നു, പിന്നെ അത് കട്ടായി.
നെഗറ്റീവ് വാല്യൂ എടുത്തോണ്ട് ഇപ്പൊ താഴോട്ട് പോസിറ്റീവ് മേലോട്ട് ആർക്കണ്ടേ?
ആ, ഒരു ലൈനിൽ അത് നോർമലി നമ്മൾ അങ്ങനല്ലേ ചെയ്യുക. ഒരു ആക്സിസ് എടുക്കുവാണെങ്കിൽ, ഒരു മിനിറ്റ്, സാധാരണ ഒരു XY ഡയറക്ഷനിൽ നമ്മളൊരു ലൈൻ വരക്കുവാണെങ്കിൽ ഈ എക്സിന്റെ മുകളിലുള്ളത് പോസിറ്റീവും എക്സിന്റെ താഴെയുള്ളത് നെഗറ്റീവും ആയിരിക്കും. അതേപോലെ ഈ ആക്സിസിനെ ഡിപ്പെൻഡ് ചെയ്തിട്ടാണ് ഇവിടെ പോസിറ്റീവും നെഗറ്റീവും ഇട്ടിരിക്കുന്നത്. അതുകൊണ്ടാണ് ഇവിടെ പോസിറ്റീവ് എന്ന് കാണിച്ചത്, നെഗറ്റീവ് എന്ന് കാണിച്ചത്. കാരണം ഫിഗർ പെട്ടെന്ന് ഐഡന്റിഫൈ ചെയ്യാൻ പറ്റിയിട്ടില്ലെങ്കിലോ എന്ന് വിചാരിച്ചിട്ട്. നോട്ട് മാൻഡേറ്ററി. ചിത്രത്തിന്റെ താഴ്ഭാഗം ആവണമെന്നേ ഉള്ളൂ, നെഗറ്റീവും പോസിറ്റീവും മാർക്ക് ചെയ്യണമെന്നില്ല. Okay, have you completed? Complete ആയിട്ടുണ്ടെങ്കിൽ ഒന്ന് അറ്റൻഡൻസ് ഇടുവോ? Please put your attendance. Please write down. Please complete the figure. അമർനാഥ് ഇല്ലേ? അമർനാഥ് കഴിഞ്ഞ ക്ലാസ്സിൽ എവിടെ പോയതാ?
സാറേ കല്യാണം മാമന്റെ.
ഓക്കെ ഓക്കെ. നിഹാലും അതുപോലെയാണല്ലോ. നിഹാൽ ഉണ്ടോ ഇവിടെ?
ഉണ്ട് സാറേ.
ഇവിടെ പോയി
പനിയെല്ലായിട്ട് കഴിയുന്നുണ്ട്. ആശുപത്രിയിൽ പോയി.
പഠിക്കുന്നുണ്ടോ? എന്നാ അധികം സ്ട്രെയിൻ ചെയ്യണ്ട കേട്ടോ. ടേക്ക് റെസ്റ്റ്. Can I close the slide? Have it drawn?
Sure.
Yes, sir.
Thank you. You can join by 2 p.m.
Thank you, sir.
Thank you, sir.
Thank you.
താങ്ക് യു സാർ.